Hello, welcome back to Edexcel Maths. In this video, I'm going to be going through the next three essential circle theorems. The angle at center is twice the angle at the circumference, angles subtended by the same arc are equal, and opposite angles in a cyclic quadrilateral sum to 180 degrees. Remember to like and share this video, subscribe to my YouTube channel, and leave a comment with any feedback or requests for topics or questions. All my videos on circle theorems can be found together in the playlist linked in the description down below, and you can find my last video on circle theorems in the card on the top right corner of your screen. The first circle theorem of this video states that the angle at the center, here angle AOC, is twice the angle at the circumference, which here in the diagram is angle ABC, subtended by the same arc. When we say an angle is subtended, we mean that it's formed between two lines which come from two specific points. For example here, the angle ABC is formed from a line which stretches from A to B, and a line which stretches from C to B. Similarly, this angle here, AOC, is formed from a line which comes from A and comes from C. So we can say that these two angles are subtended from the same points. For this rule to be valid, the two angles, the one at the circumference and at the center, have to be subtended by the same arc. In a circle here, split into two parts, we can see that there's a major arc, major meaning the larger arc going around the outside, and the minor arc, which is smaller than the major arc. The two angles in question are formed along the side of the major arc. Angle ABC is formed on the side of the major arc, and angle AOC is also formed along the side of the major arc. Therefore, these angles correspond with our rule. However, here you can see that we do have two angles which are subtended from 2 points, except one is found on the side of the major arc, and one is found on the side of the minor arc here. So this doesn't correspond to our rule, and this angle would not be twice the angle of the circumference. Contrastly, in this diagram, the two angles are formed from the same arc. This one is coming from the minor arc, the reflex angle, and this is also coming from the minor arc. As a result, this follows our rule. This angle at the center would be 2 times the angle at the circumference here. Even if you don't fully understand the stuff about the major arc or the minor arc, the more questions you do on these circle theorems, the more you'll recognize which angles would correspond to which in the same diagram. This diagram you'll see come up a lot, and this diagram you'll see come up a lot, even though it could be hidden in some different ways within the question. This is one of the ways in which it may seem less obvious, because the angle at the circumference has kind of overlapped the lines bringing the angle to the center. However, this still corresponds with our rule. To prove this circle theorem, we need to prove the following: that angle AOC, which is the angle at the center, is 2 times the angle at the circumference ABC. Drawing construction lines in circle theorem problems can make them much easier to prove. So here, we want to be drawing the construction line of a radius going from O to B. The lines OA, OB, and OC are all radii of the same circle. Therefore, they're all equal in length to each other. You can see that now we've formed two isosceles triangles, triangle ABO over here and BCO over here. Next, we're going to introduce some variables to make solving equations with the angles easier for us. So we're going to let BAO equal x and BCO equal y. Since both of these triangles are isosceles, their base angles are equal. Therefore, angle BAO here is the same as angle ABO, so we can call that x as well. And angle BCO, which we've called y, is the same as angle OBC, which is also y. Angle AOB, which is marked out in yellow, is thus 180 minus 2x, because this angle is x, and the angles in the triangle sum to 180 degrees. Similarly, angle BOC is 180 minus 2y, again because the angles in the triangle sum to 180, and we've got a y there and a y there. Using these two angles, now we can form an expression for angle AOC, which is again the angle at the center. Because angles around a point sum to 360 degrees, angle AOC can be found by subtracting angle AOB and angle BOC from 360. Once we substitute the expressions for each of those angles back into our equation, it's just a case of tidying up the algebra and seeing what we're left with. Once all of the algebra is tidied up, we find that angle AOC is equal to 2 times x plus y. However, we mustn't lose sight of what we're trying to prove in the first place, that angle AOC is 2 times angle ABC. So, now we look back to angle ABC on our diagram, and we can notice that angle ABC is equal to x plus y. Substitute this into our expression for AOC, and you find that we've proved our theorem. AOC is 2 times angle ABC, therefore the angle at the center is 2 times the angle at the circumference. The next circle theorem says that angles subtended by the same arc in the same segment are equal. In this diagram, it means that the angles marked in green are equal because they're both subtended. Again, that means formed from lines coming from two specific points, A and D, both of which along the same arc, in this case the major arc. For the two yellow angles, they're both subtended along the minor arc, so they're also equal. In the cases you can see on the left here, these two angles are also subtended from the same points. However, this one is along the major arc and this one is along the minor arc, so this doesn't follow our rule. In this case, these 2 points over here aren't located on the circumference of the circle, so again, they're not subtended by the same arc. In this case over here, the angles are subtended again from two same points. However, this one is from the major arc, this one is from the minor arc, and additionally, they're located in different segments of the circle. In order to prove the circle theorem, we must first draw the radii OA and OD onto our diagram, center. And by the rule we just proved, rule number 5, the angle at the center is 2 times the angle at the circumference. So here, angle AOD is 2 times angle ABD. However, this angle at the center also is subtended along the same arc for angle ACD. So again, this angle AOD is 2 times angle ACD. When we multiply ABD by 2, we get AOD. And when we multiply ACD by 2, we also get AOD. The only way that this is possible is if ABD and ACD are the same thing. Therefore, we've proved our original statement, and thus proved the whole theorem. The final circle theorem of this video states that the opposite angles in a cyclic quadrilateral sum to 180 degrees. It's important to understand that this rule is only valid for cyclic quadrilaterals, which means all of the vertices have to be located on the circumference. In this case, the rule wouldn't apply because only 3 of the vertices are on the circumference. To prove this theorem, we're going to want to prove that angle ADC plus angle ABC is equal to 180 degrees. These two angles are opposite, so when we add them we should get 180. We could have also chosen these two angles over here, but it doesn't really make any difference which ones you choose. Firstly, we're going to draw the radii OA, OB, OC, and OD, which are all equal in length. Next, we're going to label some of these angles with the variables W, X, Y, and Z to make them easier to work with. Notice that we've formed 4 triangles, each of which have 2 sides which are radii. Since radii are all equal, these triangles are all isosceles, therefore their base angles are equal. So we can mark in these letters which we've used onto the other base angles of each of the triangles. Now that we've marked in all of the relevant angles, we'll use the property that the sum of the angles in a quadrilateral is equal to 360 degrees, and we can form an equation using that. Once we've added up all the angles, we can form this equation. 2w plus 2x plus 2y plus 2z equals 360. We can divide both sides by 2 to simplify it further. Now we can regroup our expression on the left-hand side in a way which proves our original theorem. This expression is still the same as our statement over here, where w plus z plus x plus y equals 180. Now, looking back at our original diagram, we can see that angle ADC is w plus z, and angle ABC is x plus y, and we can sub this back into our expression. Once we substitute those back in, we find that we're left with our original expression which we sought to prove. Therefore, we've proved the whole theorem. This concludes my second video on circle theorems. Subscribe with the post notifications turned on and stay tuned for more future videos. Thank you so much for watching.